Hurricane 1 recovery of Halifax Point Pleasant Park Forest Community. So by the Earth's rotation and the sun's heat, our location are unfortunately located on the northern edge of the Atlantic hurricane system. In the past 100 years, there were two major hurricanes made landfall in Nova Scotia, which include Hurricane Jeannie in 1963 and Hurricane 1 in 2003. This hurricane has made big impact on urban forests in Nova Scotia, especially for what Hurricane 1 did to Point Pleasant Park in 2003. Therefore, we made research on secondary section and its recovery on Point Pleasant Park. So the Point Pleasant Park actually means a lot to the indigenous Mi'kmaq community. It actually means a spiritual place for them. It's a place for them to gather, to hunt, to fish, or to have some kind of ceremony. Also, the woodland region in Maritime Provinces is called the Acadian Forest, and the urban forest of Point Pleasant Park is also included in it. During Hurricane 1 in 2003, over 185 kilometers per hour of the wind speed was recorded on September 29th in Point Pleasant Park. This has made 70% of the trees in this park has been blown down. Therefore, the objectives of this research presentation aim to study the secondary section on Point Pleasant Park after Hurricane 1 in 2003 by examining the most impact forest community of the park over time, which the Hurricane 1 has made a disturbance on the park. Since the disturbance was occurred on a site which already support life, this section would be categorized as secondary section. As we can see from the picture on the timeline here, those were taken from the same spot and the differences is shocking. But in the previous research done by Scott and his partner in 2008 has shown that the urban Acadian forest can actually recover itself without any recovering plans by human.
So for our experimental methods, our sites consisted of spots of the Point Pleasant Park where there was highest disturbance by Hurricane Juan. We use 6 study sites of 20 meters by 20 meters squared, and measurements were taken each year from 2004 to 2024. These measurements consisted of density and diameter of all tree species, density of only red maple species, and density of only red spruce species. This was done by measuring the diameter at breast height with an industrial grade diameter measuring tape. And only trees that were greater than 2.5 centimeters diameter were recorded.
Research question 1 is how has the overall forest community changed over time and why? What can we predict will happen to the overall community as the forest moves toward its climax community and why? So our null hypothesis for this question is that there is no significant change in the total tree density in the forest community over time from 2004 to 2024, while our alternative hypotheses state that there is a significant increase in the total tree density post-hurricane over time from 2004 to 2024. As we look at the results, we'll talk about the pattern in tree species composition, diversity, and density after Hurricane Guan in 2003. So for answering research question 1, which is about the total density in the overall forest community, we can see distinct pattern of variation in tree density over time in the examination of forest recovery after the hurricane. The overall tree density has grown between 2004 and 2024, most likely as a result of secondary succession, in which disturbed ecosystem progressively recovered. The association between year and total density in figure 1 is statistically significant as indicated by the F statistics of 81.6 and an R squared of 0.49, which account for almost 49% of the variation in tree density. We got a p-value of 5.1 times 10 to the minus 14, which is way less than 0.05. These findings lead us to reject the null hypotheses, which claimed that there was no significant change in the overall density of trees with time, and rather we discovered that there was a favoring of the alternative hypotheses showing a significant rise in tree density over time. As we move through years, we observe a clear upward trend in density reflecting the process of natural recovery. So in 2015, we see a peak density of 283 individuals, which may indicate a period of rapid evolving for species. Following this peak, the density continues to increase and give a gradual rate. It is anticipated that as the forests move closer to climax community, competition for resources such as light and nutrients will rise, causing the total density to either stabilize or slightly decline. It is anticipated that long-living, slowly growing species will be present in this climax condition, producing a stable and well-balanced forest structure.
For research question number 2, we will talk about how has the density of the dominant species in 2004 and the dominant species in 2024 changed over time. Also, what will happen to the dominant species as the forest moves towards its climax community. For our alternative hypothesis is that the density of the both species is increasing significantly over time. So by answering the research question number 2, we want to look at the changes in density of both dominant species, the red maple and the red spruce, in these 2 decades from 2004 to 2024, since we want to know if secondary succession occurs here in this urban forest in Point Pleasant Park. So by trying to figure out the linear relationship between the density along time, the linear regression analysis was performed on both datasets for red maple and red spruce. So as we can see here for figure 2, this is the density in year scatter graph for red spruce. So we can see a positive slope here, a positive trend line here, telling us that the density of the red spruce is increasing in some way. So in 2004, 7 per 400 meters square is the data of sites with the highest density of red spruce, comparing to 21 per 400 meters square recorded on 2024. So we can see there is an increasing in density of red spruce for these 20 years. So this increasing trend was determined to be significant because as we can see, we have a p-value which is less than 0.05, which means we reject our new hypothesis. And that's telling us that there is a positive linear relationship between the red spruce density and the time, these 20 years. Although there is a positive relationship for the density growth, the growth rate is low as we can see, and this is because the red spruce is a late succession species and 20 years is actually still in the early stage of the succession. Then we also explore the linear relationship for the red maple density to the time from 2004 to 2024. From density year scatter graph here for red maple, we can also see the positive trend line here, telling us that the density of red maple is increasing as well. So this increasing trend is determined to be significant. And in 2004, we actually have a density of 0 per 400 meters square recorded for red maple, and which means we have a local extinction here. And by that, we have a recovery. So although the density for the red spruce is greater than the density for the red maple in 2004, because in 2004 we have 0 density for red maple, but by comparing to their linear equations, we can find that the red maple actually has a greater slope, and this which means that the increasing rate for the red maple density is actually faster, greater than that to the red spruce. And by these previous results, this shown that secondary succession is actually indeed occurring in Point Pleasant Park, Nova Scotia. Both dominant species, red spruce and also red maple, has both found their density significantly increasing. So at the early stage of the disturbance, light penetration to soil floors and also the nutrient availability had increased due to the depth of our tree, and the community were first dominated by the pioneer or hardwood species such as birch. But then in the late succession stage, the forest will be replaced by the longer living species and the shade tolerant species such as pine tree and spruce. So red maple here is actually categorized into intermediate shade tolerant species. So it has a higher increasing rate in such kind of early or intermediate stage of the succession. It takes about 150 years to reach a climax community. And after reaching to the climax community, the R selected species will be replaced by the K selected species with a longer living time and with a higher tolerance, such as spruce, Therefore, we can actually predict that the density of the red spruce will reach to the peak towards its climax community and remain stable until there's another disturbance. Um, for the red maple, although the increasing rate is greater than the red spruce here, 2004 to 2024, but the density of it might start declining or even replaced by some higher tolerance species such as spruce and also pine tree.
I will now introduce our third and last research question, being how has the Shannon Diversity Index changed over time, and why? And what can we predict will happen to the Shannon Diversity Index as the forest moves towards its climax community, and why? For our hypotheses, they are stated as our null is that there is no significant difference between the H prime values post hurricane to 2024. And our alternative hypothesis can be explained as that there is a positive relationship between H prime values and time following the Hurricane Juan. To answer this last research question, we used a linear regression analysis to examine the effects of Hurricane Juan and preceding hurricanes on the diversity in numbers of species, relative abundance, and evenness using tree species density and diameter at breast height from 2004 to 2024. Within the park, this is what we found as a relationship, a positive relationship between the calculated Shannon Diversity Index and time. It was also found by Houston M. that competitive exclusion within ecosystems depended on how fast species can grow and the intensity of the disturbance, which was from 1979. Here, the disturbance of Hurricane Juan was great, so this allowed enough space for more species to colonize, which created more competition and a more diverse forest community with a higher Shannon Diversity Index. It is predicted that as the forest moves towards its climax, the Shannon Diversity Index will remain at a constant, with dominant species outcompeting any new growth.
A number of ecological principles can be used to analyze the rise in tree density variance during the past several years. The shift to a clean ecosystem where late successional species with different rate of growth began to dominate is one significant reason. Since certain regions mature more quickly than others, this leads to unpredictability. Variation may also be influenced by growth responses particular to a species. So when various tree species compete and establish dominance in different locations, their growth responses to the same environmental conditions will vary, resulting in a variance in density.
The characteristic of both species can explain the density change over time. Red maple is an intermediate, shade-tolerant species, and it can be successful when the urban forest is not dominant by loss of tall evergreen tree yet. However, toward the late period of the succession, urban tree will be dominant by more shade-tolerant evergreen tree, such as red spruce. Therefore, the both density increasing slope will change over time.
The last question that we have received from the audience is how would you expect the Shannon Diversity Index to shift over time as the forest begins to reach its climax community? Here, we think that the dominant species will remain the most composition makeup of the forest, being red maple and red spruce. The Shannon Diversity Index will continue to increase after 2024. And we think that the H prime value will remain at a constant once the forest climax is reached, because with any more competition or new species will be outcompeted by the pioneer species.
In conclusion, our predictions indicate that Point Pleasant Park is probably moving toward a mature Acadian forest, and it is in a mid-succession stage. The ecological dynamics of the park may be impacted, for example, by human activity. However, this evaluation also recognizes that habitat damage and decreased vegetation cover may make it more difficult for native species to establish. Furthermore, the quality of soil and water may be impacted by the urban pollution, which may also have an impact on natural succession process. Using the Mi'kmaq concept of two-eyed seeing could offer comprehensive forest management strategies to support Point Pleasant Park significance of ties with the land, in addition to quantifiable ecological effects, we can create a more resilient ecosystem by putting into practice forest management techniques that respect biodiversity and community involvement.
We'd like to thank you all for listening and for participating in the discussion, and we'd like to acknowledge a few people. Elder Albert for the two-eyed seeing concept within this research project. Furthermore, we'd like to acknowledge Dr. Allison Schmidt for the data analysis and the figure creation. And finally, all the students and professors for assistance in collecting the data for paired sites from 2004 to 2024. And this being 20 years was a long time with a lot of people helping, so we'd like to acknowledge them. And thank you.